right.
Hey, Mr. Ray.
Good evening, everyone.
Good evening.
Good evening.
Good evening. How's everybody doing?
Pretty good, pretty good.
That's good. That's good. Just trying to let some more people in. So I'll just be writing people's names down as you guys come in as well. And let me just check to see if anyone is stuck. Sometimes we have those who can't log on or having some issues. So in order for me to see that, I have to minimize the screen. So if you're waving or trying to get my attention, I want to see who that might be.
Hello, Mr. Ray. Hello, everyone.
Good day.
Hey,
All right, so let me just start getting the names down of those who are here. All right, so we have Daniel. Welcome again, Daniel. Daniel C, that is.
Mr. Ray, how you doing?
I'm doing well. Thank you very much.
I saw that.
All right, and good day, good evening, Ray. All right, thumbs up, Clemente. Good evening to you as well. Latavia, good evening to you.
Good evening.
Carlos, good evening.
Hi, good evening.
How are you doing today?
Pretty good, thank you.
I like your backdrop.
Oh, thank you.
Looks pretty sharp there. All right, Lenore. Good evening. Veronica.
Here.
Good evening as well. And Maceo, welcome back.
How you doing?
I'm doing well, thank you very much. And Maritza. And good evening to you. Maritza, this your first time? Okay, yeah, I thought so. No, just to let you know you're muted, but I can see that you're saying yes. But all right, so you'll catch up in a moment, but do you have the two books, the student book and the workbook? Did you get it from the school? You give me a thumbs up if you did get it. Okay, perfect. All right, Dorcas, welcome again.
Yes, I'm here. Good evening.
Good evening. And Beatrice.
Yeah.
Good evening as well. Beatrice, you're new to this class, right?
Yeah.
Okay. And welcome as well. Hopefully you have the two books that the school gave up.
Yeah, I do.
Okay, perfect. And where am I? Dorcas, yeah, and Susanna Rodriguez. Okay, Sergio, welcome again. And Norma. Norma, can you remind me of your last name? Is it Norma Gomez?
No,
Or
Mesa.
Vila? Say it again?
Mesa.
Mesa. Okay, thank you. I have a few Normas in different classes, so sometimes they get mixed up. All right, and William, welcome again.
Thank you, sir.
You're welcome. George, good evening.
Yeah. Good evening to everyone.
And Daniel N. Good evening, Daniel N.
Yeah.
And Marisol, good to see you again. Good here. All right, let me have Justine. She's coming in. Justine Moreno. All right, so I should have 19.
I need it. What?
Okay. Did I skip somebody's name? Did you not hear me call you?
Marisol Sanchez.
Okay, so 18. Somebody just left.
Mr. Ray?
Yes.
Hi. I don't know if you called my name or not.
Yeah, I called you. Your name was still, your mic was still connecting, your speakers.
Okay.
Yes,
Okay,
I did
thank
get you,
you.
but thank you for checking just to make sure. But I'm when I count, I'm missing one person. 1, 2, 3, 4, 5, 6.
Gotta be one of the Daniels.
That's possible, you know. Let me check again. And it was one of the Daniels. Great. All right, so thank you. Oh, let me get Gennaro, just came in. All right. And man, everybody's coming in once I put my book down. Adriana. All right, so let's go ahead. Any questions about the homework or the worksheet?
Yeah, Mr. Ray, I get
Yes.
lost. I get lost where we have the minus because you use the arrow. Try to elaborate it to me. Let me understand.
Okay, so you mean something like 3 minus 5?
Yeah, when you do the other way around, I don't get it well.
All right, so let's just do a few of those, and hopefully that just clarifies everything for all of you. You should see my white screen there to write on. And if we had the number, say 3 subtract -5. So is it you forget the rule or the concept? George?
Yeah.
Okay, all right, so, well, just a reminder. What we do is whenever the negatives are right next to each other like that, we're going to turn it into a positive.
Okay.
So that becomes 3 plus 5, which is 8. Now, sometimes when we see a lot of negatives, it can throw us off, but we just want to remember the rule is that when you have the 2 negatives right next to each other, nothing else in between, like this, then that turns into a positive. And so that would become -4 plus 1. And -4 plus 1, hopefully everyone remembers how to do that, would be -3. Right? And sometimes what happens is we get thrown off by questions like that. But notice the negatives are not right next to each other. The number 1 is in between it. And so there we can remember not to circle it and add it, only when the negatives are right next to each other and there's nothing else separating. So here, -1 subtract 3 would be -4.
Okay.
Right? And then remember, the reason why we subtract goes back to the number line. And the best way to see it with the number line would be like the question number 1 with the thermostat. If we had like -3 here and 5, well, they had the other way around. But let's just say it was -3 and 5. I don't feel like erasing it. We had -3 and 5, and 0 was in the middle, and the temperature changed from -3 up to 5. Remember what we would normally do, like if we had 2 here, in order to find the distance between 5 and 2, we say 5 subtract 2. But here, and remember, this is not the same as the first one. Let me just do it. That way I don't throw anybody off. What we had, 3 and -5, right? What? Right, here we go. 3 and -5, right? That's what we had. That's why I didn't want to erase it. So we have 3 and -5. Remember, to find the distance between 3 and 2, we would just say 3 subtract 2, and that's 1. So we do the same thing here. To find the distance, we say 3 subtract -5. And the rule that we have to notice that that's a +8 movement, we circle that. You don't have to circle it, but you need to know that those two negatives turn into a positive to get the 3 + 5, which would be 8. Right? And so that's why we do that rule. The rule comes from a real life situation. If you were looking at a thermostat and you lived somewhere colder, like it's Colorado, there's snowing in Colorado and Wyoming, right? I'm not sure how cold it got, but let's just say it went down to -5 and then quickly goes up to 3 degrees. It has to go past 0. And so you count the 5 units up plus the 3 units, so that becomes 8. But the way that we actually do it in real life is we just find the distance between the two and subtract them. And so we say 3 subtract -5. We know the answer should be 8. And so our rule that we have is whenever the negatives are right next to each other, nothing else separating them, we turn it into a plus sign. Right? So that's one that normally does throw people off. Does that help, George?
I'm still doubting because here we have 3 minus 5. I was thinking it's supposed to have been -3 minus 5 that will give you positive. That was how I was thinking.
So wait, you said -3 minus 5?
5.
Yes, that will be that's going to turn to, if you do the rule, you have -3 plus 5. And
Yeah.
-3 plus 5 would be +2.
-3 plus, it will be +2.
Right.
Okay. That's why I always have doubt.
Yeah, so the key is just to remember those two negatives. Let's try a few. I'll put a few up just to make sure everybody remembers how to do it. And like I said, the negatives normally throw people off, but once you understand why we're doing what we're doing, it makes it easier. Remember, think money, and whenever this happens, just remember to change it to a positive. All right, so I'm just making them up as I go. So let's say we had 12, -12, subtract 3, call that number 1. Number 2, we could say, I don't know, 4 minus 6. Number 3, let's do -8 plus 4. 4, let's do 3 minus 7. And one more just to make it more like our fingers. -7, let's see, subtract -8. Okay, so let's see what we get for those. And for those of you who were not here on Tuesday, this is based off of Unit 1, lesson something. Let me see, lesson 3 talks about integers. So go ahead, try to see what answers you get in doing these operations. All right, and welcome Gennaro and Adriana and Salvador. You guys came in while I was teaching.
Hello, Mr. Ray.
Hello, Mr. Ray. Sorry for the being late.
Okay, I didn't catch who that was, but thank you for coming. Okay, Salvador.
Yeah.
Yeah, so thank you for the apology. Just glad that you are here. All right, so some of you guys are sending the answers in. I see some private and another one, everyone, a public one.
The last one is -1.
Veronica, that looks like they're all correct.
-15.
Yes, those are all correct. And I want to acknowledge the public one yet, as I do want everyone to have an attempt. So if you want me to say if you're correct, send it privately.
How do you send it privately?
If you send it privately, if you see the chat, you should see 2, and then like everyone, there's a little arrow right after everyone. If you click down, you can click the names, or you could click my video screen and you can do the 3 dots that are there I think you should see 3 dots on my face. And if you click on that, you see chat. You can click chat on that.
Okay.
Okay. I see some more. You shouldn't have any fractions. So if you're sending an answer with fractions, you want to check that over. This one is integers, so you should still get an integer. And remember, integer is a whole number, the negative whole numbers, and positive numbers themselves. All right, Daniel B is in here. All right, so I see some more in the private chat. Okay, and I will respond to you if you have something wrong via the chat.
Okay, let me see.
Okay.
Oh, just got it from you, Dorcas, and that's correct. Well done, Dorcas.
Hi, sorry I'm late. Daniel
Minus
Borges checking
15.
in.
All right, got you, Daniel. Good evening and welcome again. All
Sorry,
right, so
late. Running a little late, doing a little bit
yeah,
of errands.
that happens. It's evening time. 6 o'clock is a hard time because if you're knocking off 5, you gotta get home, set up, do all that stuff. So totally understandable.
Thank you.
You're welcome. All right, so I did get a few more coming in.
Okay.
Minus 3.
All right.
All right, so I got a good bit coming in. I can't respond to everyone now. So some of you saw that I sent some answers in, but we do want to get to it as time is ticking. So let's go ahead and check the first answer. The first one, what should the answer be?
-9.
I heard -9.
I got
Negative 15.
I heard
negative 15.
And I also see +9, and I also see +15. So we have 4 answers that I've either was told or I see in the chat. And of course, one of them is right. So remember, you can always think money unless this situation pops up. But if it's not that
Minus
situation, just think money. Remember, negative, think of that as owing somebody money. And subtraction is the same thing. You owe money or you're giving more money away. So if you owed someone $12
Minus 15.
and you took away $3 more, meaning you gave them $3 more, or you borrowed $3 more rather, so you're taking from your account, how much would you owe altogether?
15.
Negative 15. Right? The negative indicates you're in debt still. And then the 15 represents the actual number. So let's say I borrowed $12 from you, and by you, I mean you. And then I said, can I borrow $3 more? How much money do I owe you? And how do you represent that so that people know that I owe, right? You know it's 15, but you need the sign to indicate that the person is in debt, like you give me money, right? If you saw that in your bank account, you're not gonna be that happy, right? And so that sign is really important. because with or without it determines a lot of different things. It determines up versus down, left versus right, east versus west. All right, how about this one here? What would be the answer?
-2.
I got -2.
Hey, that one sounded unanimous. That is correct. It's a -2. Once again, you can think money. You have $4.
Yeah.
And you take away 6, or you owe someone 6. It's payday. You give them the 4. You still haven't paid off the debt, right? It means there's $2 left. And how do you show that $2? Negative sign.
Yeah. The money thing helps me out.
Oh yeah, the money would really
I
help.
looked at it, I
Money
was like,
helps
I
out.
got 4 and I owe 6. I got.
Yeah, when it comes to money, we're normally pretty savvy. All right, so we're at -8 plus 4. Once again, think the same thing. What would
-4.
-4, correct, right? Owe someone $8. They come, they're like, I need the money. You give them 4, or they give you 4, right? They owed you the money. Let's put it that way. I don't want to keep putting people in debt. So you're the person, you're the lender. You lend out $8 to the person. They come, they're like, here's 4. How much more do they owe you? $4. How do you show that they owe you that? Negative. And that negative sign is important, because if you remove the negative sign, then you need to give them $4 in a sense. All right, this is fourth one. What we do here? What is the answer?
10.
10. Now remember, this is the one where it's kind of hard to say it in monetary form, but using a thermometer makes a lot of sense. And so what we do is we change that to a plus sign. It becomes 3 plus 7. And 3 plus 7 gives us 10. Right, and if you need me to draw it, you can ask me, can you draw that diagram again? So does anyone need me to draw it out again? All right, good. Do I hear yes?
Yeah, me. That was
Okay.
I was on that last one.
All right, so I'll draw again why we turn that to a plus sign. So this is number 4's explanation right here. So for number 4, if this was a thermometer, right? The thermometer had 3 degrees Fahrenheit, was 0 here, and then we have 7 below 0. 7 below 0, we say negative. And that looks like a 30, so I'm just going to erase the degree sign. Now, if I had, as I said before, if I had 1 degree here, what is the difference between 1 and 2? I mean, 3 and 1.
It's
2.
2, right? And the way that we get that, to find this distance, we say 3 subtract 1. That's how we know the difference between 3 and 2. And depending if we're going up, we say positive 2. If we're going down, we say negative 2. So if I want to find the distance between 3 and -7, I follow the same rule. I'm going to say 3 subtract -7. But I can look here and count how many units that is. In order to get from 7 below 0, I'm going to have to go up to 6 below 0, 5 below 0, right up to 0. And that's 7 units right there. If I change the color from -7 to 0 is 7 units. And to get from the 0 to the 3 is how many units?
2.
3
3 units as well. How much is that all together?
plus 10.
That's 10 units. Now it's plus 10 if I'm going up. If I was going down, how much would it be?
Minus 10.
Minus 10, right? So it depends which way I'm going. So since I'm going up, because that's the way I'm really going, that's why it's plus 10, because we are actually subtracting to see what that difference is, and it's 10. Does that make sense? Why we change it to addition?
So basically, the number 4, Mr. Ray, it's 3 minus -7.
Yes, it's 3
Oh,
minus.
okay, got it. I thought it was equal.
Oh, yeah, my bad. But yeah, that one's 3 minus 7.
Yeah, how you explain it on the top, on the 3 minus -5, it converts to positive, right?
Right.
Plus. Okay, got it.
Yeah, whenever those 2 negatives are right next to each other.
Got it. Thank you for the explanation. I appreciate it.
You're welcome, and I'm glad it helped. All right, so, and it helps if you explain it. Most people do not understand integers. That's just a fact. More than likely, you know somebody that doesn't understand it either. if you explain to them how to do it, then it can help both of you out. Just in case that threw you off, that's a negative. So we have here -7 subtract -8. What would be the answer here?
1.
-1.
I heard two different ones. I hear 1 and -1. Look at it carefully. Think money as well. Remember, this one is 2 rules here.
Oh.
You have a minus
Turn
minus.
it into a plus, right?
Yes,
It's
turn
plus
that
1.
to a plus, right?
+1,
It
yeah.
becomes -7 plus 8. And -7 plus 8.
It's 16.
No, 1.
1.
1. Why is it 1?
Plus.
Well,
Because
Because
that's
the 7 is negative and the 8 is positive.
right.
right.
8 is
Treat this -7 like somebody owes you money, right? Let's say somebody owes you $7. How do you represent owing money? A negative sign. You ever hear, man, I'm in the negatives. Negatives means that you're in debt, right? Your credit card, any credit cards that we have actually represents debt. So it's
So,
negative. Out of
Mr. Ray,
that -7, you owe somebody owes you $7, right? They pay you, they give you $8. How much is left over?
1.
1. So you got to give them that $1 back. It's an excess that's left now.
I have a
Can I share
question.
something? Go ahead.
Okay, hold on. I had Clemente accent and then someone who went to
Yeah,
share.
okay, if there's a minus next to the 7 in the front of the 7, and the 2 minuses that are in between the 7 and the 8, they turn into a positive, right?
Right.
Okay, but the first one, it still stays as -7,
That
right?
still stays -7. Yes.
Okay, I got you.
All
Thank you.
right. Okay, and someone else went to share something?
Oh, I just wanted to share something that helped me a little bit understand better, but I don't know if it's correct for you. I don't know if you can see that. So like
Yeah. Go ahead. You can share that. I had mentioned that on Tuesday. You could share it again.
Oh, okay. I just wanted to make sure because I wasn't too sure if I got it in class, and it just it helped me understand a little bit better. So like the bigger number is
Right. So what Leonora is doing
yeah.
is that if the bigger number, well, it's this one now. If the bigger
Yeah.
number is positive, then the answer stays positive.
Okay.
Right. So that's
I'm
another.
just having troubles understanding like the diagram, I guess, or the other part, and that's how they help me understand it, to just look into like the bigger number on top, it's plus, so because it's bigger, and then the smaller number, it's less.
Right. That's what I'd said on Tuesday. The alternate way of looking at it is to say you just subtract the numbers. So just anytime you see a negative, you just subtract it. So you just say 8 minus 7. And then whichever one has the bigger sign, you keep that sign. So if it was the other way around and it was -8 plus 7, you still subtract it, get 1. Since the 8 has got the bigger sign in this one, then the answer gets the sign.
Okay.
Right, so that's the alternative.
So it's okay that I go by this explain.
That's fine. That's fine. The only reason I don't stress that one is because I really want people to understand why we do what we do.
Okay.
So I don't mind you guys doing that. It's just that we do really want to make sure, especially when you get up to the problem solving with algebra and geometry, you really want to have an understanding of why we do what we do. For this one here is just based off of the thermometer reading, that well, we don't really use thermometers anymore. But for those who may remember, the thermometers, how the scale works, you're just subtracting. So the practice makes progress. The more you do it, the better you will get. Now, I sent a worksheet in Remind, and if you're new, you don't have Remind, you want to make sure you get Remind before the class is over. And if you haven't downloaded the worksheet and tried it, you want to try it. The worksheet has more problems to try. You're not really going to see that many problems in the workbook that are just like this, just answer the question. In the workbook, they're going to ask you more real life situations. And so now I'll switch it over to that. Any questions from the workbook or the worksheet, either one?
Yeah, I got one. I was hoping we could do one.
Worksheet.
From the worksheet.
Okay, from the worksheet. Let me just bring that up real fast. And you could just tell everybody what number.
It's 75 minus Negative
Okay,
83.
if you're gonna read it, I'll just, actually, no, I'm gonna bring it up. Just bear with me real fast. Sorry, George.
Okay. I had a question with that.
I just want to make sure everybody could see what worksheet I'm referencing. Now, this is in Remind, and
Yeah.
I'm just gonna reshare. Okay, so which one you said?
75 minus negative 83 in parentheses.
Where's that one?
It's in the middle bottom, the last in the middle.
Oh, okay, I see it. All right, so this one here, use accent for the final answer. So remember, what would you do
actually,
here?
what would be the best way to look at it and do it? Because usually the math, sometimes I get confused because there's some I think multiplication when I see parentheses.
Oh, okay, I see what you're saying. Yeah, parentheses, it's just how they wrote it. I didn't create this one, someone else did. You can have parentheses around every number. This person's just doing it because they, more than likely, when they get to algebra, we really stress putting the negatives in parentheses. And so more than likely, they're just doing it so that whoever uses their sheets never forgets.
I had another question with that. Since it's a minus and it's a negative, you know how we turn that into positive since they're both negative? What would it be? So it's basically 75 plus 83.
That's it.
Okay. The parentheses throws me off.
Yeah, that's a good question. It's just that's the choice.
So we don't have to worry about the parentheses then, right?
No, you didn't need the parentheses. You could, like this one here, you just
Because
put
it
it
was
in like that.
confusing in a way.
I thought they were for a reason.
Guys, just so you know, guys, I took the practice test this morning and I passed.
That's good.
However, all the questions are in parentheses.
Oh,
Every single number was in parentheses. So that's just good to know. Every single problem that had to do with this was in parentheses. All the numbers were in parentheses.
I'm glad you said that, Daniel. So did everybody hear that? All the numbers actually look like that.
Yeah.
Yes.
I think
But it's basically the same, right?
That's how it's specified on the book also, just parentheses and all the equations.
Yeah.
And the practice the skill.
Right. So that's the way that they're going to do it. So that's the way you could practice. It's just that the parentheses will be there.
Right.
Yeah. In some worksheets you won't see it, but since you're practicing for the GED, then that's what you want to definitely do, is stick with whatever method that they
And
have.
again, only reason I know is because I took the test this morning. So like I said, I passed it, but it was interesting that everything, I hadn't seen it that way before. I was seeing how you were doing it, Mr. Ray. And it threw me off a little bit at first, but then, I figured it out. So.
Oh, great question, Gennaro. I'm glad you were here to affirm that, Daniel, with the parentheses, because for me, it doesn't bother me, but yeah, if you're not used to seeing it.
I understand that it's only multiplication in algebra. Is that true?
No, parentheses are just used to group something. They're used to group something, and what's being grouped is the number with the sign.
Maybe I'm thinking slopes or something.
Say that again.
I think I'm thinking slopes. I've done stuff.
Yeah, you're thinking, because what happens is we have different levels of math, and GED just encompasses all of them. So when in elementary math they do multiplication like this, That's what we call cross product. But when you get to pre-algebra and algebra, they stop using the cross product because it looks like an X, and we use a lot of X's in algebra. So then they use the parentheses, or they use
a
dot product, right? So
yeah,
that's what's possibly throwing you off. But the difference here is that the sign is always going to be a sign in the middle to change that. It's multiplication when there's nothing in between it. So if you saw this,
then you multiply.
You multiply because there's no plus sign, there's no subtraction sign. Even if you see a negative here, the negative belongs to the 3, and there's nothing in the middle of the two quantities that are in the parentheses.
Okay.
There's always, when you see something in between the numbers, even if it's parentheses, if there's something in between them, that's the operation that you do.
Yeah.
With
So
multiplication, there's no
you guys are
operation.
going to see everything like at the bottom number there on the 3rd row. That's how everything's going to be.
No, the negative 36, that one?
Yeah, that one.
Oh, okay.
So that's how they did them all that way. I think there was 3 3 different problems there, but they were all that way, the format.
A lot of word problems too.
Not a little bit of everything, a little bit of everything.
Those are my favorite.
Yeah.
Struggle with those.
Still mine.
All right.
Just go to Crunch.
All right, so Daniel had Daniel C.
Same thing with the soy milk. They have
Yes.
it there.
Was somebody else
just
talking?
The chai in what size? The 12 ounce.
Okay, so I was picking up someone else's conversation. As Daniel C. just said, the practice test is a great asset, great tool, especially when you get closer to wanting to take the test. The school does provide a GED voucher at times, and if you're really wanting to take it, we could possibly get one for you. They only cost $6, so they only give it once, I believe, at a time. So you can always take it whenever you want to see have you improved. And it gives you a great readout. Daniel, you should have saw that they said something about which pages or something. If you got something wrong, there's like,
Yes, I did. I linked it up to the book, to the student book, and they gave me a whole spreadsheet of. I have to improve like in 8 different areas. So I'm going to. I scheduled my actual test because they're up in October now. So between now and October, I'm going to concentrate in that area of the math to improve, and I should be fine. But you know, I'm going to still participate in class, and I'm going to try and also on the side go a little further in the book. So,
all right. And Daniel, what you can do, send me a message at the end of class. Since you're taking your test early, I'm going to link you up with something we do with the HSE class.
Okay.
Yeah. So just remind me at the end of class, and I'll get that to you. It'll help you since you're planning to take the test.
Yes.
All right. Okay,
Thank you.
You're welcome. Did that clarify the question there? And I'm so glad you brought that up, Gennaro and Daniel, for confirming this about the parentheses. Is everybody clear with how to use the parentheses if you see it?
Yeah, they do now.
Yes.
Okay, so yeah, like up above the negative 61 in parentheses, that's basically just negative 61 minus 26.
Right.
Right.
That's
Okay.
basically it. And once we get to the calculator usage, I'll show you how to do that on the calculator as well.
Okay.
All right. So remember, this is in the Remind chat group. This worksheet.
Oh, that reminds me. I'm sorry. By when should I have my calculator?
We're not going to get to the calculator use until some time. So you could get it and you could just learn it on your own, but I'm not going to do it until possibly October.
Oh, all right. I got time. I thought like next week or something.
Oh, well, no, not yet. I really want to make sure you guys learn the concept first, because there is a non-calculator portion of the test, and so you want to be able to do any calculations that are needed.
Okay.
Yes.
Yeah.
And if you take the test at Fontana, they don't even let you take in your calculator. They put mine in a locker, and they give you one there. So
yeah, and it has to be the TI 30XS.
Yes.
So you want to learn
Yes.
how to use it.
That is correct.
Yeah, they give you a TI 30XS, and I'm guessing they gave you the yellow one, Daniel. And
no, actually, it was just like mine, the bluish greenish.
Okay, I guess they.
And it was just like mine. They just didn't allow me to
take yours. Yeah.
To take mine in.
Yeah, the reason why some calculators are programmable, so
yes, you can
people
program.
cheat. Yeah, they put information in their calculator and then try to bring it up later.
Yeah.
All right. So if there are no other questions about integers, we're going to move on. So now is the time if you have any other questions, if it's from the workbook or the worksheet. Remember, the workbook would have more real life questions. So going once, going twice, and looks like we're going to move on since everyone is ready to get an A. If I was to give a test today.
No.
Maybe a B.
Or a C.
You said, say it again?
A C.
A C. All right, so ask one more time. I really want to make sure, because integers, you will come again on integers in algebra. You have to understand graph.
I get it now. I was just I mean, I took it in the class before, like twice. This is my third class, and I could have sworn something about parentheses makes you want to multiply and all that.
Yeah,
Wait a minute.
you are correct in that sense, but remember, whatever's in the middle of the two numbers.
Okay. See,
all right.
Mr.
Okay,
A.
so, yes.
I came in late, so do the parentheses mean anything, or are we just ignoring them?
So the parentheses is just to make sure that you don't mix up the signs. That's the real reason why people use them, like mainly for these ones. So actually it came up today. When I wrote this, it actually looked like to somebody like an equal sign. So it gets a bit confusing. So to do that, most times they put it into parentheses. And it's normally just a negative number, as you see here. But I think the GED, they put both numbers into the parentheses, whereas this worksheet only does the negatives.
Okay.
Yeah, so it's really just for clarity's sake, is to make sure that you could clearly see that you are subtracting a negative 79 there, or subtracting a negative 41, so that there's no confusion. Okay, all right, so if there's no other questions, let me go ahead and we're gonna move on to fractions. Who likes fractions? Anyone likes fractions? All right, so let me get control of my screen again. Let's see. All right, so we're going back to the text, the student book, and I don't remember the exact page, so, and I might have cut off the page by mistake. This is the calculator that you have to get. So those who want to get the calculator, I might as well bring it up now, especially because we have some new students in the class. This is the TI-30 Access Multiview. That's the only calculator that is allowed on the test. And as Daniel said, they don't even let you take your calculator on the test anymore. They're going to provide you with one. So you do want to know how to use it, and I will be teaching you how to use the calculator. It's a very powerful calculator. It can do fractions for you, mix numbers. It can change numbers into decimals and percentages and vice versa. It can even do tables for you so that you don't have to actually do the table when you want to graph. It does so much, but you just have to know how to use it. So, you know, but first, before doing that, and whenever I teach it, people are like, man, you should have just taught us this. I don't need to know how to do the working. No, you do need to know how to do the working. While you're here, right, we want to learn how to do the working. You never know, battery could die. You try to get into a program and they say no calculators allowed. A lot of programs, when you do certification tests, do not allow for calculators. The reason why a calculator is allowed for the GED, because they have a lot of algebra in it. And so it allows you to actually do other stuff with it. But many certification tests and entrance tests, exams, no calculators. So once again, that's a TI-30 Access. Costs about $15 or so on like eBay, Amazon, like $17 in Target and Walmart if you go to the store. So you can get one. The book, both books, all the books, whether it's science, social studies, language arts, or the two math books, have this on inside the book in the Roman numerals for 12 XII. If you turn to that page in any book that you have from the GED, you will see this calculator and you will see instructions, and you can teach it to yourself before I even get there. All the information that you need to know for the test is found in these pages. And when I go over it, I might show you some more stuff that they don't cover, like the tables. They don't cover how to use the table, but I'll do that as well. But you can learn the calculator just from those two pages. So get the calculator, you can play around with it, but we do want to practice doing these things without a calculator. Daniel, one thing I want to say to you, this page here, that's the formula page for geometry. I can possibly share a video from another class on how to do that, so you can practice that on your own. But that's a page that you definitely want to get familiarized with. And they do give you the formula page on the test. No, I did the wrong way. But you do want to get familiarized with which one is which. All right, so now let's move on to fractions. And where is fractions? All right, here we go. All right, so fractions. People either like them or hate them. But they are very important, and many of us know how to use them, and we do use them. When you're measuring to make food, whether it's like pancake mix or cake or cream and wheat or something, drink mix, right? You're going to see stuff like half a cup. If you are into construction and anything dealing with measuring with a tape measure, you're going to see those little notches on there. And those little notches represent fractions. And so we're going to learn how to simplify fractions, add them, etc. So first of all, a fraction shows part of a whole or group of part of a group by separating the two numbers with what we call a fraction bar. So that fraction bar, my computer's, okay, here we go. That fraction bar, that looks gimpy. That fraction bar also means to divide, but it's literally saying part of a whole. That's what the fraction literally means. It means I have 3 out of 4 things. The denominator, which we call the bottom number, that's the denominator. That tells you how much you have. It's the total amount. I'll just put denom. Denominator is right there. And then on the top, we have the numerator. And the numerator tells you how many parts that you have. So when you say part of a whole, or 3/4, 3 out of 4, you're saying I have 3 parts out of a whole. Now that's all in your book, so you don't really need to write all that down. I'm just going to switch it over just to try to get you guys to see it a bit more. So part of a whole, one of the best ways to really understand what a fraction is to use, I do have a circle, what we call pizzas. Everybody likes pizzas and pies, right? So if you were to take a pizza, I don't know what happened to that pizza. Oh, there we go. Right, if you was to take a pizza, right, and cut it into a half, and say that's my half, and then on one side, this is the side that I ate, right? How many pizza slices did I eat? The one that's in red.
One.
One out of how many?
2.
1 out of 2. And that is what a fraction is. A fraction is literally just saying, how many did you eat? Now, what we also need to learn about is what we call equivalent fractions. This is the basis of all of our operations for equivalent fractions. And this is how we add, subtract, whether it's a mixed number or whatever it might be. So what happens if there's another pizza, exact same size, right? And if it doesn't look the exact same size, assume that it is. Right, and this pizza is also cut into a half. But instead of cut into a half, I eat a half, but it's cut into 4s. And I eat half the pizza again. Have I eaten the same amount of pizza even though I have 2 slices there?
Yeah, this time
Yes, I have, but what's my fraction now?
2 parts.
2 over 4.
2 over 4, right? But that's still half of the pizza. What if I do that again and I cut it now into more slices? How many slices will I eat now in the shaded region?
4 over
2
8.
over 8.
4 over 8. Is that still half of the pizza?
Yes.
Yes, it is. What if I keep doing that and I cut it again into another half, right? And I cut that pizza up. That looks horrible.
That looks terrible.
Does it? Do it that way. How about I cut it again? And how many slices would I have eaten now?
16.
It's 16 in
I
total.
would think, yeah. 8 over
And
16.
I've eaten whatever, 8. So you notice all of these fractions are the same. 1/2, 2/4, 4/8, 8/16. These are all equal amounts of pizza. Does that make sense?
Yes.
Yes.
Now we're going to use that concept to help us to add. What if I wanted to add half plus 3/4? Now, when most people see this, what do you think the most common answer is?
1 1/4.
Okay, so you figure that one out fast. One of the most common answers you would hear is 4 over 6, right? People just can't beat the temptation to just add it that way. Well, the thing is, you can't add fractions that way because it violates something that we all can see, right? If I was to make these and assume these are equal pizzas, let's say for the first one, I ate half of the pizza. And for this one, this person. Actually, let's do it this way. I know you might have copied that, but just let's bear with me for a second. This way I can really push. There we go. All right. Let's say the pizzas were cut this way, and this is my pizza, and this is your pizza. Is that fair?
Yeah.
No.
I have a slice, and you have a slice.
No, that's not fair.
Why is not
It's a
fair?
small-
We both have slices, don't we?
Ours is smaller.
Half.
But you still have one slice, though. I have a slice, you have a slice, everybody's happy.
A smaller slice.
So that's not fair because you guys say this is a smaller slice, right? Well,
Right.
that's the reason why we can't add them. We can't say there are two equal slices there. We can't say 1 + 1 because those slices are not the same. What is the only way to make that fair?
I have 2 fourths. Then
Right, we're gonna have to change the amount of pizzas there. So if I cut the pizza now, one more time, now I have 4 slices of pizza. And that's what you have to do when you add fractions. You have to make sure that the denominators are the same. If the denominators are not the same, you can't add it. It's just go, just think if my denominators are the same, it's like having unequal pizza slices. And so now that I've cut it into 4 slices, how many slices have I really eaten?
2.
2 out of 4. And now, how do I add those 2 fractions together?
That's 3/4 of a pizza gone.
3/4 of a pizza gone, right? 1, 2, 3 out of 4. So what do I add in the fraction? Do I add the numerators together? The numerator is the top number.
No.
Do I add the numerators? The numerators are the top
Yes.
number.
Yes.
Yeah.
Do I add the denominators together? That's the bottom number.
No.
Right? So when
No.
you're adding the fraction, the first step, number 1, is to make the denominators the same.
So I have a question.
Yes.
To make them the same, will it be the bigger number always?
Well, that's the easier way. You can do the smaller number, but that can create a lot of headaches. So just to make it easier, we always teach, and every teacher will normally teach that, make it to the bigger number.
Okay.
All right, so we're going to make the denominators the same, and then the second step, once the denominators are the same, add the numerators. And the numerator is which one?
The top.
Top number. So I'm not going to say top, I'm going to say numerator, and I will say denominator. Which one is the denominator?
Bottom.
Bottom number. And what do we do with the denominator? We keep it the
same.
And you can see that. You can visually see why we keep it the same. Because how many pizza slices were eaten? And if you was just to say the total amount. If I ate how many pizzas? I ate 3 pizzas out of a whole, which is 3 out of 4 in this case. All right, so let's go ahead and see how we actually do that. The way that we make the denominators the same, well, we noticed that's a 4, but what we also noticed that we doubled the amount of slices. And what number represents doubling?
2.
2. So what I really did, I doubled the denominator and I doubled the amount of slices that I ate. And that's how we get the 2/4. And so we have 2 4s plus a 4 gives us 3/4. And that's literally what we're doing with fractions. We're doing what we can just see in common sense land, right? We know that we can see it, but now we need to write it down. We need a way that we can have it written down without having to draw boxes all the time and pizza boxes. We needed a numerical way to do that. And that's what those rules mean. It's simply coming up with a way that we can clearly write it and other people can understand it. All right, let's try some more. And what if I had 1/3 of a pizza plus, say, 1/9?
My glasses, I need.
Right? Now cutting those pizzas up are gonna get harder now, right? If I was to try to draw a pizza with 9 slices, that's gonna get pretty difficult, right? So now you see the reason why we want a numerical way to do that. Because trying to draw 9 equal slices and trying to count them, and your children might be doing that. That's what they have the children doing now, that doing math with boxes and stuff. But we need a more efficient way to do that. So before we do that 1/3 plus 1/9, let's just look back again. Notice we wanted to get the denominators to be the same, and we chose the bigger number. Does anyone remember the name of what we just done there? We spent some time on it. Begin with an M. We were finding common.
Find the common multiply.
Yeah, we're finding we're finding the LCD. That's what is commonly known as, or the LCM, the least common denominator or the least common multiple. That's exactly what we did. The least common multiple between the 2 and the 4 was 4. And so we just simply say, well, what can I multiply the smaller one by to get to that number? And that was 2. And so here with 1/3 plus 1/9, what could I multiply the denominator 3 by in order to get 9?
3.
3. And what I do to the bottom of the denominator, because I'm increasing the amount of pizza slices, I need to do to the amount of slices that I'm actually taking, right? So if I had 1/3 of a pizza, and I cut the holes up, the question is, well, what happened to the amount of pizzas that I ate? Let me do that a little bit slower. That looked crazy. Right, so a pizza's cut into 1/3. Let's say I ate 1 slice. Right, but then I want to make sure I have enough slices to match the other one. So I cut this one, I cut this one, and I cut this one. Right, so now I have 9 slices of pizza, but my pizzas have changed as well. So the same way I multiply this by 3, I need to also multiply the top by 3. Because now my amount of slices that I've chosen has also increased. All right, so I'm having some problem with my pen. Hold on real fast.
Yeah.
All right, so we times that. So we times this by 3, and what we do to the bottom, we do to the top. And so what would be my new fraction for the first one? 1 times 3 is
3.
3. 3 times 3 is 9. And I have plus 1/9. And remember, what do I add in the fraction?
The top.
The top. So 3 plus 1 is
4.
4. So I'm left with 4 over
4/9.
Now, just in case you forgot about the lowest common multiple, what you would do on the side would be you have your 3 and your 9, and you will want to see what are the common multiples. And the multiples of 3 are 3, 6, 9, 12, 15, etc. And then 9 is 9, 18, 27, etc. Right? And you can see the lowest common multiple, or sometimes known as the LCD, lowest common denominator. When we're dealing with fractions, we normally say lowest common denominator. When we're just dealing with the multiples, we say lowest common multiple. But the lowest common multiple of those is 9, and that's why we're trying to figure out what do we multiply the 3 by. And the way that you know what to multiply the 3 by, if you're writing it out the long way, would be the position. That's the first, second, third. And so 3 times 3 is what gives you the 9 in order to have the same denominator. And now you see why everything builds upon itself, why we had to learn about factors and multiples, etc., because we're going to use them to add fractions. And these are the easier fractions, but we're working our way up to those larger fractions. Any questions so far?
Nope.
All right, let's try some more then. All right, so let's say I had, I'm gonna just put here number 1. We had 2, come on, 10. We have, let's say we had 2/3 plus 3, not 3, plus 1/6. And then number 2, let's say we had a half plus 5/8. Let's try those two. So 2/3 plus 1/6, 1/6. And then number 2, 1/2, which is 1/2 plus 5/8, 5/8. So go ahead, work those two out. Remember, your denominators should be the same.
Got it.
All right. If you get your answer, just so that others can have a chance to work it out, just go ahead and send it in the chat. And you can write it, for example, just doing like a slash, using the slash option and then the other number. So this would be the same as 3/4. So if you want to send it in the chat, that's how you can do it. And the slash is near the question mark, pretty close to your space bar if you're on a computer. All right, let's see what we have. And was somebody asking a question? I thought I heard some talking. All right. Okay, so I see some answers sent.
Oh my God, I can't, where's my slash?
All right, so it looks like everyone is getting the same answer there. Sending it at least.
Oh, okay, I found it. And then how do I do this one?
All right, so for the first one, everyone that has sent in a fraction has sent the same answer in so far. And that looks like everyone's got it. And that's really good because you guys would be like one of the first classes that I had that didn't have so much problems with fractions, which is a good thing. So we could actually move faster if everyone actually gets it. All right, so everyone's given the answer. What is the answer that we should have here?
5/6.
5/6, right? And so for this one here, and I see some of you remember how to do mixed numbers, which is good.
I have
one,
1/8.
Okay, for the second one, I'm hearing that, so we could jump right into that once we get there. All right, so let's go ahead with the first one. The denominator 6 is the bigger one that we want to match it up to. So what would we multiply that 3 by?
2.
2, right? And just trying to get my pen to work. So yeah, we times that by 2. And what we do to the bottom, you do to the top, right? I'm having some issues with this pen today. All right, so we have 2 times 2 is going to give us 4, and what's 3 times 2 is 6, and plus 1/6 is going to be equal to
5/6.
5/6, right? And that's the answer for the first one, right? And you can even represent that with pizza pies or whatever you want to call it. We can even use different other objects as well. All right, so let's look at the second one.
Mr. Ray?
Second one, I'm seeing, yes.
This is Clemente. How do you get the 1/6? Okay, you equaled it to 4.46, and then you put the plus and the 1/6. How do you get that 1/6?
That 1/6 is from here. It's the same one.
Oh, you just carry it over.
Yeah.
Oh, okay, got you.
Yeah, just in case that throws people off, what we call this is, and I didn't really explain it. This is what we call the identity. So it's not really an equation. What we're saying is that this expression here is the same as this expression here. So we're just saying they're the same, and all I'm showing is the progress. So think of it like a little cartoon figure, like, you know, you draw the head, and then the next thing you're gonna do is draw the feet, but it's still the same person. You're just showing the progression of the same thing. So I'm gonna be doing that a lot, especially in algebra. Sometimes we do it below each other. So we write underneath, but that's what that means. Just showing the identity relationship. All right. Okay, so, and hopefully everybody can make that out. All right, the second one, a good bit of you seem to know and remember how to do mixed numbers. So I might as well just throw it in here now. I wasn't going to do it yet. All right, so what would be the denominator that we want to have in common here?
4.
8. Okay, well, we're going to multiply 4 so that we can get 8, right?
Yes.
2 times 4 gives us 8. And what we do to the denominator, we do to the numerator, right? And so that's going to give us, for the first fraction in this new identity, 1 times 4 is 4. 2 times 4 is 8. And then we're going to add those two together. All right, so 4 over 8 plus 5 over 8 is
9/8.
9/8, right? So we get 9 over 8. Now, some of you already went and made that into a mixed number. I know some of you may not know, some of you may not remember, and so let's go over what a mixed number is.
1 over 1/8?
Yes, that would be the answer for a mixed number. It's going to be 1 1/8, and a few of you guys know that already. Yeah. All right, so just to show you what a mixed number is, and we're going to be coming back to the mixed numbers again in decimals and in other areas as well. All right, so for the first one, we had a half of a pizza. You could think of it that way. All right, so that pizza was cut into half, whereas this one is cut into 8ths. Easy to use those lines. All right, so that one is cut into 8ths, and what we're seeing is there's a half a pizza there, and then this one here is 1, 2, 3, 4, 5 8ths of the pizza. And you want to see how much pizza. So let's say it's like a little party, and one of the pizzas is cheese, one's pepperoni, right? And so this person here is hungry. He took a whole big half, and he's like, I'm gonna get 5 slices of the other one. How much pizza slices did he eat in all, right? That's basically what that question can be saying. So when you redo it, instead of me drawing another circle out, I'm just gonna use that pizza there. We need to make the other one into 8 slices as well. And so when we do that, we're gonna have 1, 2, so we're gonna cut it so that it's now an 8. And now you see that's 1, 2, 3, 4 slices. Now, if you were to put all those things into one big pizza, you're gonna see, let's say I took the slices there and put them into the other one, and I'll change it with a different color. So imagine I'm taking the slices over, and now I have 1, so I'm taking that one out, 2, taking this one out, 3, taking this one out. How about that last slice? Still there.
Right?
Sure. So 1
now
and
we have a whole pizza here. That's the 1. And then we have this 1 slice out of 8 that's left over. Does that make sense?
Yes.
Yeah.
That's visually what we do when we turn an improper fraction. We call it improper because the part is bigger than the whole. So we call that an improper fraction. And we want to turn the improper fraction into a mixed number that shows us how much of the whole we ate, plus the little portion that's left over. So I ate, let's say it's me, I ate a whole pizza, and then there's still 1 slice of cheese left over out of the 8 slices that are there. So it's 1 out of 8. So now we need a process in order to change that number that some of you may know. And there's a variety of ways you could do it, but traditionally we say, how many times can 8 go into 9? You're literally dividing. And so you may, did we do long division? Yeah, we already did some long division. We learned that A divided by B is equivalent to saying B into A, but I did not go over that as a fraction is the same as A over B. So that means if you don't know how to get into a mixed number, you could use long division to help you out. And if you need me to write that back up, I can. So that means as A over B, you can write it as 8 into 9, right? So this will come in handy later on with some other mixed numbers. So you're basically saying 9 divided by 8. So 8 goes into 9 one time. 8 times 1 is 8. And when you subtract it, it leaves you with a remainder of 1. Now that remainder, we write it as the quotient with the remainder over the divisor. That's how we write it. The quotient plus the remainder over the divisor. Now, traditionally, we just do it in our heads. We just say 8 goes into 9 one time with 1 left over, 8. But that's what a mixed number is. And we can show that visually. We could connect it to a real life situation because that's what mathematics is. Mathematics is simply the study of everything around us and how to put it on paper.
All right.
Right?
So, Mr. Ray, if on that 9/8, okay, visually, if it were 11 over 8, would my answer be 1 over 3/8?
Yes, it'd be 1 over 3/8.
Okay. The pizza got me confused, but yeah, visually,
Okay,
like
the pizzas are confusing. The pizzas. I know it works for some people and some people doesn't.
because I was looking at the 9/8, I'm like, there's one. It's 1 over the 8, because 8's supposed to be the what's that, the
Denominator, yeah.
That's like the whole.
Right, and that's what happened, right? It's a whole
we went
pizza.
over one. We went over one. So okay, so I see it now.
Yeah, it's a whole pizza.
Yeah.
And it's still 1 left. I couldn't fit this one in the box if you could think of it.
You
I
got
put the
1 and you got 1/8. Okay.
Right, I got a
That's what I
whole
was asking.
pizza.
If that 9 were to be, let's say 11, my answer would be 1 and over 3/8.
Right, if it was 11, then I have this one pizza there, 9, 10, 11. So then one pizza with 3 left out of the 8 slices.
Okay, got it.
Right? Okay, any questions? Because I wasn't going to do improper fractions yet, but so many people had given it, I said it might as well go over it. Any questions about that? Maybe the mixed number, maybe it's the addition part.
We're good.
I'm still a little confused.
Okay, with which part?
I mean, doing the mixed number, getting the 1 and the 1/8.
Okay, how to get it?
Yeah.
All right, and do you understand the pizzas at all, or does that, don't worry about the pizzas right now?
I mean, if there's an easier way.
The easier way would just be just knowing how many times 8 can go into 9. So what we're doing, basically, the fraction bar, this thing right here, that means to divide.
Mm-hmm.
So you're literally saying 9 divided by 8. Now, just think about the multiples of 8. 8 times 1 is what?
8.
8. 8 times 2 is?
16.
So can 9 be divided by 8 evenly?
No.
No, and it can only go 1 time. So 9 divided by 8 is 1. And then what you do is you simply subtract the 2 numbers. So what's 9 subtract 8?
So
That's your
basically,
remainder.
you divide the number on the
1.
bottom.
And then you leave the same denominator. Say it again, Carlos.
Yeah, we just divided the number on the bottom. How many times if it goes in the one on the top, right?
Right. How many times can it go? 8 goes into 9 1 time with 1 left over.
Okay, got it.
That's all you're saying. How many times? Now, I didn't want to go into mixed numbers yet. We're going to come back to it. So if you didn't quite understand it, just hold on. We're going to do a little bit more addition, and then we'll come back to the mixed numbers. So for now, we're just leaving them as fractions. If you want to write it as a mixed number, you can. I just don't want to have too many concepts at once right now. So let's go back to adding. All right, let's say we had 1/4 plus 1/5. And then I'm going to throw in a challenge one here. What if we had, no, sorry, not 1/5 yet. I wanted to say 1/8. The challenge one was going to be 1/4 plus 1/5. All right, so the first one is 1/4 plus 1/8. The more challenging one is 1/4 plus 1/5. And if you, from now on, we're going to wait till we get to the mixed numbers. I just don't want to overwhelm everyone.
Can we say the answer?
Say that again. Okay. Not sure if you're talking to me. If not, I'm just going to mute everyone. And once you're ready, just unmute your mic.
Got him.
All right. So, okay, you put in the chat.
I have 3/8 and
Okay.
9/20.
Okay, here are the two different answers, and let's see what's in the chat.
Yeah, that is number 3, 3/8. Then number 4, 9/20.
Okay, so I heard two answers there, and Latavia, I see yours as well.
So, Ray, can I ask you a question while we on?
Yeah, sure. Go ahead.
So on the numerals on the bottom, obviously they're not the same. So we multiply by 1 and make it the same before we get our answer on top and bottom, right?
Yes, you have to make the two on the bottom the same.
Okay. And however I get the bottom to be the same, that's how I do the top on each.
Right, there you go. Whatever you do to that fraction, you do to the same numerator of that fraction.
Got it. Done.
All right.
So what would we multiply 4 by?
Depends which one you're looking at.
The number 4.
Okay, number 4, it's a challenge one. I threw it in there to see, you know, where you guys are standing. You need to make sure that the denominator of both are the same. So think about that, same, something that's in common between the two.
I've done number 3 and number 4. Number 3, the answers is 3/8.
All right, George, I got your answers. You said 3/8 and 9/20. Just giving everyone a chance to get that.
Okay.
If anyone else is finished, I'll give you another one to try out. Let's try out some subtraction, see how good you guys are. So this is for those who are finished and want to try out something there. So we're gonna have 2/3 subtract, let's say 4/5. So for those of you who are finished 3 and 4, go ahead and try number 5. And that's a combination of two topics, one that we just finished. Okay, number 5, just a reminder, that is a challenge question. So, just be mindful of that one. Okay, so let's start the other ones. I see a lot of answers coming in. We have up there 1/4 plus 1/8. So what do we do with that 4? Well, we see that they both can go to 8, right? We're gonna make that 8 the bigger one. So we can times the 4 by what? And remember, your mics are all muted if you're trying to talk.
By 2.
By 2, right? And what you do to the bottom?
You do to the top.
To the top. What you do to the denominator, do to the numerator. 1 times 2 is 2. 4 times 2 is 8. All right, and then over here we have the 1/8 that we had before, and we just add the numerator. So 2 plus 1 is 3, and then we have what on the bottom? 8. Right, and so that's how we get the 3/8.
We don't change the bottom number?
No, the bottom number stays the same, and that's what I was trying to show with the pizzas. The reason why we have what we have goes right back to real life situations. That 8 stays the same.
Okay.
All right, so number 4 might have been tricky for some. I see some of you already knew how to do that, which is good. Number 5, be careful with number 5. Be very careful. The numbers can be right. You just want to make sure your signs are okay. All right, so we have 1/4 plus 1/5. What do we do there? Notice that I can't multiply 4 by anything to get 5, and I can't multiply 5 by anything to get 4, but I'm multiplying, and I'm trying to find something in common.
Lowest common multiply?
There we go. We're looking for the lowest common multiple, right? And I try to use the actual words. I'm multiplying, and I'm trying to multiply to something that's in common. That's our lowest common multiple. So you want to get the theory behind why we do stuff. Nothing in math is stupid. Everything is based off of reality. So I'm trying to get something that's in common. And what is in common between the 4 and the 5?
20.
20. Now, the more you know your multiplication chart, you know your multiples, the easier it is. If you don't know your multiples that well, you're going to have to write it out. And you're going to have to say the multiples of 4 are 4, 8, 12, 16, 20, 24. And you see why you want to practice those multiplication charts that I sent, 28, etc. 5, you got 5, 10, 15, 20, 25, 30, etc. And you see that the lowest common multiple, because they do have some more multiples in common. You have 40, you have 80, 120, but you want to choose the lowest one. If you choose the lowest one, it makes it easy in the long run. All right, so what we have here is, if you're unsure which one to multiply by, you can look at the position. That's 1, 2, 3, 4, 5. So you're multiplying the 4 by 5. What you do to the bottom?
Do to the top.
You do the top. And for the 5, you notice that that's in the 4th position here. That's 1, 2, 3, 4. So 5 times 4 is 20. All right, so once you get that, 1 times the 5 is 5, 4 times the 5 is 20, 4 times the 1 is 4, and 5 times the 5 times the 4, sorry, is 20. And so now you have common denominators. Because your denominators are in common, you can now do what with the numerators?
Add them.
Add them, and 5 plus 4 is
9.
9. So you get 9 over 20.
20.
All right, so for those ones, you have to make the denominators the same, and you do so by finding the LCM. Now, you can multiply them by each other, and some of you may know about cross multiplication. My preference is to stay away from cross multiplication because when we get to ratios and when we do some other things, confusion sets in, and it's just always happens. So I prefer not to teach cross multiplication if you know it when we're doing adding, because if you're a methodical thinkers are like, tell me the steps, that's when you can get confused. And so it's better to know specific methods for each one, especially on the GED test when you're being tested over grades 5 to 10. And grades 10 math now is basically what used to be college math for most people. So we're doing a lot of different stuff. You don't want a lot of different methods to be confused. All right, so we're making the denominators the same, then we're adding. Now the same thing happens with subtraction. And let's see, number 5 was a challenge one. Some of you finished very fast, so I gave one that would course a little bit more thinking there. I see 3 answers have popped up. But before we get there, any questions with number 4?
No.
Okay, so no questions with number 4. All right, let's go ahead and try number 5. I see 3 of you have sent in answers. 1 of them is correct, and 2 of them are close.
I have a -2 over 15.
Okay, I hear -2 over 15 for the answer. Some of you are just catching up, so go ahead and try that one. Similar concept that you did with number 4. Think about the section that we just finished and make sure that you don't leave that part out. And think about the section we just finished was on integers. All right, seeing more answers pop up. Now, if you see, some people are sending it privately. So let me see if it's to everyone yet. All right, if you would have heard George. George said -215, and then we're seeing 2 over 15. So think about that. One of those 2 has to be right. 2 over 15 or -2 over 15. Which one is correct? You can have both.
It's actually negative.
-2 over 15.
Okay, so I'm hearing more -2 over 15s popping in. Right? Negatives are important. And so you will be penalized. And if you haven't noticed yet, if you've been practicing from the workbook, you will see many times a similar number, but the only difference is a negative. Sometimes you see -5, 5, 10, and -10 as choices. And so one of those is right and one is wrong. And so having a negative or not having a negative can decide whether or not you lose points. All right, let's go ahead and do this one. What would I have to do here to make the subtraction possible? What has to be the same?
Find the multiple.
I need to find the common multiple between the two. Now, I could just multiply the denominators. That's the fastest way. Sometimes it's the fastest way, rather. But it's not always the lowest common multiple. But what is the lowest common multiple between 3 and 5?
5.
15.
15, right? Multiples of 3 are 3, 6, 9, 12, 15, etc. And then we have 5, 10, 15, 20. So 15 is the lowest common multiple. There are many common multiples, but it's the lowest, and that's the one that we want. So what do we multiply the 5 by?
3.
3. What we do to the bottom, we do to the
Top.
top. And same thing over here, we multiply the 3 by
5.
We do to the bottom, we do to the top. 5. All right, and so our new fractions will be 2 times 5 is
10.
10. 3 times 5 is
15.
15. And then we're subtracting. 4 times 3 is 12. And 5 times 3 is 15. Now here is where the rules that we just learned come in. Integers and knowing how to subtract. Yes, you will have to subtract fractions and possibly get negatives. We have 10 subtract 12 in the numerator. We know the denominator stays the same. So what is 10 subtract 12?
2.
Not just 2. Minus
2.
Right? We just learned about that. If I have $10 and I take away 12, I'm in the negatives. So that answer would be negative 2/15.
Negative.
All right, so remember the rules of integers. Everything that you learn in Unit 1 carries on in every other unit. So whatever you learn in integers, you will see it again in algebra, geometry, statistics, or probability, right? Whatever you learn stays in the whole system. So if you see a negative and you see that your number is smaller, you must have that negative sign there. All right, so negative 2/15. You guys seem to be doing very well. I think we can up the ante a bit and go right into mixed numbers. Actually, I forgot to do one more thing, is how to reduce fractions. We learned about equivalent fractions, such as 8/16. And let me just put a title here. This is simplifying fractions. Or at least I'm trying to write a title. All right, simplifying fraction or reducing fractions. We need to go over that. I believe some of you, based off of what I'm seeing, know how to do this already. So sometimes they say simplifying, sometimes you might see it written as reducing. But simplifying and reducing fractions is using the concept of equivalent fractions to get a fraction to the lowest possible terms. So if I have a pizza, I eat half of the pizza, but the pizza is cut into 8 slices, so that I eat 4 out of 8. In any test that you take in this world, if your answer comes out as 4/8, you have to reduce your fraction to its simplest terms. So if I ate 4 slices out of 8 pizza, how much of the pizza do I eat? Most people say you ate a half. And that half is an example of the expectations, that you are to reduce it to its lowest terms. If you got 4/8 after you work it out, you will not see 4/8 in the selection. It will not be there. It will not be there. You will have to reduce that fraction to its lowest terms. And the way you do it is the opposite of what we just done. Instead of doing the multiples, we do the factors. And we're going to divide the fraction by the greatest common factor in order to get to its lowest terms. Now we can clearly see that's a half. And the way that we do it, we find the greatest common factor between 4 and the greatest common factor between 8. That's the long way. Now we need to know the long way, because when you get harder numbers that you're not used to, you're going to have to be able to figure out the factors. Here is a bit easy. The factors of 4 are 1, 2, and 4. 1 times 4, 2 times 2. The factors of 8, I've been telling you guys to write out them in pairs, so let me write them out in pairs. We have 1 times 8 and 2 times 4, right? So we have 1, 2, 4, and 8. So what is the greatest common factor between the two?
That's 4.
4. So this one is the greatest common factor. So make sure you know the difference. Greatest common factor goes with simplifying or reducing. Lowest common multiple goes with the addition and subtraction. So that means we're going to divide this by 4 in order to get it to its lowest terms, which we already know to be 1/2. 4 divided by 4 is 1. 8 divided by 4 is 2. And that's how you get it down to its simplest term, 1/2. Now, that's going to happen when you're adding. When you're adding fractions, you're going to start to see fractions pop up that are not in their lowest terms. They're going to have common factors in between. And the expectation is that you're going to reduce it down to its lowest terms every single time, whether it's probability, whether it's in geometry, statistics, algebra. That is the expectation no matter what test you take, GED, SAT, GRE, GMAT, whatever it is. The expectation is that you always simplify it the same way we do in words, half of the pizza. So let's try out a few fractions real quick just to make sure everybody can simplify them. Let's say you had 3/12. Reduce that to its lowest terms. The second one, at least I'm trying to, that's number 2. Let's say we had 16 over 36. And number 3, say we had 15 over 45. So for each of these, we're going to reduce that to its lowest terms. You have to do that for every question. So remember, to do it, you want to find the greatest common factor. So number 1, find the GCF. Remember, GCF stands for greatest common factor. As we learned, sometimes they might write the largest common factor. They may write the highest common factor, just anything synonymous with that. You're finding the factors of the two numbers, and you want to choose the biggest one. If you don't choose the biggest one, you have more work to do. Right, the second step, find the GCF, and then divide both the numerator and denominator to simplify. I'm just going to put the N and D. So that's the numerator and denominator by the GCF. And GCF, remember, means greatest common factor. If you're not sure, just let me know and I can write it out. Divide both the numerator and the denominator by the GCF to simplify. And once again, the more you practice your multiplication tables, the easier it is to simplify. After a while, you'll see you don't even have to write it out. It'll just be in your head. Okay, so I'm seeing some answers pop up there. And I think you sent that privately, yeah? So Latavia, that is correct, yeah. Since you sent it privately, I can confirm it for you now. Okay, Dorcas, that's correct as well.
Number 2 is 1.
All right, Daniel, that is good. Daniel C. If you get a message from me, I'm more than likely telling you to check 1 or 2. So just make sure you read it. And if I say the last 2, that's number 2 and 3. The last one is number 3. Now remember, if you don't choose the greatest common factor, you're going to have to reduce it multiple times. So it's not that you can't choose any factor, it's just that you won't be able to reduce it all the way. And if you stop, you still won't get the correct answer that's shown in the multiple choice selection. So keep in mind that you want to choose the largest common factor. All right, let's start off now with the first one. And if I sent you to fix one, just check it over. Starting with the first one, if I wanted to reduce this, remember that's the title, we're simplifying this. I want to divide both the numerator and the denominator by something that is in common. If I can't, then it's already in its simplified form. Just keep that in mind. If you're there and you can see that, you just say it's already simplified. All right, yeah, Veronica, that's that last one. All right, so let's go ahead with the first one. What can I divide number 1 by in order to simplify that completely?
3.
3, right? 3 is the greatest common factor between the two of them. Now, if you can't see it right away, remember you want to write out the factors of 3 and 12. And let me just stick with the instructions. The factors of 3, well, that's a prime number. So prime numbers only have 1 in itself. So 1 times 3. So there's only 1 and 3 for that one. Now for 12, you might want to write out the patterns. The reason why is if you leave out 1, you can be up the creek. So 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and then 4, well, we already have 4, remember, so we stop there. That's all the factors. So you write out 1, 2, 3, 4, 6, and 12. And you can see already 3 is the greatest common factor. And so that's the one that you divide by. You found the greatest common factor. Now you divide both the numerator and the denominator by that greatest common factor, which is 3. So 3 divided by 3 is 1. 12 divided by 3, 4. So that simplifies to 1/4. So if you ate 3 pizza slices out of 12, you have eaten a quarter of the pizza. And that's how we talk. We talk in simplified format. All right, so 16 over 36. Well, what would be 16 over 36? What would I have to divide both numbers by?
4.
Okay, I hear 4. And if you know your multiplication charts, right, you know them, it makes it easier. 4 is the answer, but once again, just in case we need to see it, you would want to write out the factors of 4, and it helps to keep them in pairs. So 1 times 4, 2 times 2. So that's 1, 2, and 4 for the first one. And then, so I'm doing 4. That's supposed to be 16. Sorry about that. So for 16, the factors of 16 are 1 times 16, 2 times 8, Can 3 go into 16? No, we skipped that one. Can 4 go into 16? Yes, and because we see a repetition, then that's the end. So 1, 2, 4, 8, and 16. And then the factors of 36, 1 times 36, 2 times 18, 3 times 12. Then I'm gonna have to write it up here because I don't have room.
4 times.
4 times 9, and 5 doesn't go into 36. 6 can go into 36 6 times, right? 6 times 6 is 36. All right, so that means the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. And you just want the ones that are in common. And we have 1 in common, 2 in common, 4 in common, right? 4 is the highest one that is in common, so that's why we divide it by the 4. Once again, for those who have been here, I shared the multiplication chart, and the more you practice that, it should just come to your head faster. So we divide this by 4 on top and bottom, and that now allows me to simplify my answer. 16 divided by 4 is 4. And what is 36 divided by 4?
9.
9. And so that's my simplified fraction, 4/9. Okay, any questions so far?
No.
Okay, the last one, number 3, I had a few answers where it wasn't reduced to its simplest terms. And so I'm going to review that. And let me show you real quick with this one. We see the answer there. Hopefully everyone has it written. You see that there are other common terms here, such as 2. If I had divided this one here by 2 instead, I would have had to do it 2 more times. So if I divided this by 2, I would have got 8. And if I divided this by 2, I would get 18. But that's not simplified. 8 and 8 are both even numbers, which means it can keep on simplifying. And so I have to divide it again. And I'm not going to do a second set of factors. And you can see why you would choose the greatest common factor. I have to divide it by 2 again. And if I don't know those factors, I'm going to have to do another set of factors if I don't know it off my head. And so 8 divided by 2 gives me the 4, and 18 divided by 2 gives the 9. Now, many people, they're like, oh, I'm done. But no, you won't be done. You will not see that answer there. And that can panic. That can cause panic on a test. You know, when you don't see the answer and you know you've done it right, and you start to panic. So the thing is, you want to remember to do it by the greatest common factor. In a multiple choice selection, 8 over 18 will not be there. Only 4/9, unless it was a specified question where they wanted the actual amount. But other than that, it's guaranteed that it'll be in its simplest form. So please keep that in mind. I'm going to erase this green. Hopefully no one needs that to do the last one. And I'm seeing more of the answers pop up for the last one. Make sure you reduce it completely. And so you'll find the factors of 15 and 45. We've already done the factors of 15 already. There were 1, 3, and 5, and 15, right? And we did that in a previous one. And then 45, the factors of 45 are 1 times 45. Can 2 go into 45? No. Can 3 go into 45?
Yes.
Yes. How many times?
15.
15. Can 4 go into 45?
No.
No. Can 5 go into 45?
Yes.
Yeah.
Yes. How many times?
9.
9 times. Can 6 go into 45?
No.
Can 7 go into 45?
Nope.
Can 8 go into 45?
No.
Can 9 go into 45?
Yes. You already have it.
Already have it. So that means we're done. We found all the factors as we learned before. So now the factors of 45 are 1, 3, 5, 9, 15, and 45. So what is the common factors? Well, I have 1, 3, and 5 in common, and also 15. So what is the largest common factor between them?
15.
15, right? 15 is actually the largest common factor. Be careful. 5 is normally a common choice. But 15, although 15 is a number there, 15 is the largest. that gets me straight to my answer without any extra work. If you chose 3, you're going to have to do it 2 more times. If you choose 5, you're going to have to do it 1 more time. If you choose 15, you're done. So we divide this by 15, top and bottom. And what's 15 divided by 15?
1.
1. What's 45 divided by 15?
3.
3. And that's how you simplify fractions. Now you're going to have to do that all in one, right? Most questions are going to ask you something, and I say Johnny had 15 over 45 something and 2/3 of this. How much did he have? You add the two together, and then you realize that you need to simplify that answer. You're going to have to simplify down to your final answer. And so we're going to be combining everything up pretty soon. Any questions about simplifying or reducing fractions? Okay, so if there are no questions, we're going to go right back to mixed numbers. Some of you, like I said, already seem to have an understanding of mixed numbers. Normally, the pizza graphs help, but it looks like the pizza graphs are not really the choice here, so let's just stick with the numbers. A mixed number, I'm going to do a pizza. A mixed number is when you have a whole amount, right? And then a portion of another amount, part of a whole. So for instance, this case, let's say this pizza was cut into 4 slices, both of them. And in this pizza, I eat the whole box. I ordered 2 boxes of pizza. Here I've eaten a whole amount. But then I'm really greedy. I try to eat the next one. I'm stuffed and I can only eat 1 of that. Well, then how many pizzas did I just eat out of that slice? I mean, out of that box?
1/4.
I ate 1/4. So that's 1 plus the 1 out of the 4. Now, instead of writing the plus sign every time, we remove the plus sign and we write it as a mixed number as so. Now, this is really important because many students get mixed up and they think that a mixed number means to multiply. We are not multiplying 1 times a quarter. We're saying 1 plus a quarter. Does that make sense?
Yes.
Keep that in mind. That comes up often to know the difference. A mixed number is saying 1 plus a quarter. And we're going to come back to that with decimal numbers and percentages. It means to add. Now, how much would I have if I actually did it in terms of a fraction? Well, how many slices did I eat altogether?
5.
5 eighths.
I ate 5 slices out of how many in terms of the base number? 8. Right? So, well, not 8, sorry. I got caught up with everyone. What is the base number?
4.
4, right? The whole is 4. So I ate 5 slices out of a base of 4. So this is what we call the improper fraction. And the other one is what we call the mixed number, but they are the same. They're just different ways to represent it. And what we want to do is just make sure everyone understands how to go in between it. So if I was to turn the improper fraction into a mixed number, that's what everyone was just asking. Now there's different ways, so let's try the 2 main ways. Most times people say, how many times can 4 go into 5? Or how many times is 5 divided by 4? Well, how much would you get?
1.
1, right? 4 can only go into 5 1 time. The multiples of 4, 4 and 8. You can't go 2 times because 4 times 2 is 8. So it can only go 1. But how many is left over?
1.
1. Out of how many?
4.
4. And that's how you see the connection between the mixed number and the improper fraction. One is just saying that I ate a whole amount plus the fraction amount. The other one is saying how many slices did I eat out of the base. But they're both the same thing. And so sometimes, and in GED, they always want your answer in mixed number. In high school mathematics, if you have a student in high school, one of your children is in high school, they can leave their answer as an improper fraction. So if you guys start talking between each other, you're going to say turn, he's going to say you don't have to, etc. Right? But both are the same number. But in the GED, if you get an improper fraction, you have to turn it back into a mixed number. Is that clear?
Here.
All right, so that's what we want to practice now, is turning improper fractions into mixed numbers. Now, before we do that, I also want to just show you how to turn a mixed number into an improper fraction. And so we'll do that on either side.
So it's not necessary to use a plus sign, right?
No, it's not necessary, but you do want to understand what it means.
Got it.
Right, because a lot of times, and this happens often, people see the mixed number, and then when we learn how to multiply fractions, they try to multiply it. And it's like, no, that's not, we're not multiplying.
Okay.
A mixed number means 1 plus the fraction. But we just get rid of the fraction sign. I mean the addition. All right, so on one side, we're going to practice turning fractions. My pen is really acting up. On one side, we're going to turn, we got 8 minutes, so yeah, we should be able to finish that. On one side, we're going to turn improper fractions into mixed numbers. And the other side, we just want to go over how to turn mixed numbers into fractions. And we're doing all this so that we can learn how to add mixed numbers. So turn mixed numbers into fractions. And so on Tuesday, when we come in, we're going to be adding mixed numbers and fractions and mixed numbers. All right, so for the first one, if I want to turn a fraction into a mixed number, and when I say fraction, I mean improper fraction. So you can write that in there. I'm just trying to work on time, so just make sure you know that's improper fractions. So let's say I have number 1, and let's just say I have 12 over 8. Number two, let's have 13 over 7. Number 3, 15 over 4. So we're going to turn those into mixed numbers. And then I need to go over how to do this one first. And so I'll just make room for that. And I think we have time. And this one, we're going to turn the mixed numbers into fractions. So let's say I had 2 1/2. I'm going to turn that into an improper fraction. 1 2/7 into an improper fraction. And 3 1/3 into an improper fraction. So to do that, just to give an example, let's say I have 4 3/7. In order to do that, it's a long process and a simple process. The simple process is the only one I'm going to show. Is that you're going to multiply the denominator and the whole number together. So you multiply those two. And then the result, you're going to add them to put a plus sign there. So 7 times 4. How much is 7 times 4?
28.
28. And then you're going to add. That's a plus sign. At least I'm trying to make it into a plus sign.
31.
Right, and then you add those together. So 28 plus 3 is going to give you 31 over 7.
Okay.
Now, there's a longer way to do it, but we don't worry about the long way. The long way is why we do what we do. But that's the rule. It's 31 over 7 because we're going to multiply the denominators and then add the numerators. So I'll draw the signs on here since this is obviously where we're going to end tonight. So multiply and add. Multiply, they're touching each other. Multiply and add. So you're going to multiply these two.
4 plus 1, 5 over 2.
Add.
Okay.
Multiply and add. And just for time's sake, let me just go over it with you. So for the first section of turning the mixed numbers into improper fractions, we could do this together. How many times does 8 go into 12?
1.
1.
Ones, with how many left over?
4.
4 over how many?
8.
8. Are we done for that one?
No.
No, why?
You can simplify.
You have to simplify it.
Yeah, 4 and 8, you can simplify that, and you will be expected to. So what can I divide them both by? Hopefully you can see it.
2.
4 is the bigger one. So you're going to actually divide both of them by 4. That would get you straight to the answer that will be in the multiple choice. So 4 divided by 4 is 1. 8 divided by 4 is
2.
2.
right. So that's 1.5. Okay, how about this one? 13 over 7. 7 goes into 13. How many times?
1.
1.
1. So how many left over?
1
Five.
going back to
With
7.
5?
Yes.
6.
6.
Oh, my bad.
Yeah, with 6 left over. So 1 and 6/7. Okay, and then the last one, how many times does 4 go into 15?
4.
3.
3.
3, right? 4 times 3 is 12. And what's the difference between the 12 and the 15?
3.
3.
3. So 3 and
4.
3/4, 3 and 3/4, right? So that's how you'll change those ones. And there we do some more practice. I'm gonna send a worksheet for you to practice it. To change a mixed number into an improper fraction, I already have this set up for you. And that one there, if I change the color, we do 2 times 2, which is 4.
Plus 1 is 5, so 5, 2.
5 over 2. And what you can do to practice this, you can try to take these and get them back to that. And vice versa here, you can take the answers and try to go back, right? Since you have them there, you can just practice going back and forth. For this one, we have 7 times 1, which is 7.
9 over 7.
And 7 plus 2 is 9, so 9 over 7. And then for the last one, 3
10
times
over
3 is 9, plus the one that's correct,
10
10
over.
over 3. So like I said, you can take these ones that you've practiced. Like for instance, let's say I take 5 over 2. I can see what the answer should be. It should be 2.5. And I could practice doing that. 2 goes into 5. 2 times is 1 left over, and I get a half. That's right. Cool. Right? When you do that, you can see, you can practice over and over, because you will have to do this as we go forward. Even if you have the calculator, you see at times you're going to have to write it out, especially in algebra and geometry. Although you have the calculator, you're going to have to work it out with the calculator. So you do want to practice, because all of this is building up so that you can do the algebra and geometry. But unless you can master Unit 1, algebra and geometry is very fishy. Most people have troubles in algebra and geometry because there's something in Unit 1 that we don't quite get. And that's why I say ask a question. If you don't get it, ask it, because it's going to build and build. And then that's when, just like a foundation, if the foundation's messed up and you keep building, eventually the thing will collapse. You have to fix the foundation. So next week, I'm going to put the worksheet on there. You can try some of the problems in the workbook if you have some memory of how to do fractions. If you're unsure, then I'll say just work with the worksheet. Any questions though in the last minute?
Can you do back number 1?
Say that one more time. You sounded far away.
Can you do back number 1?
Can I go back over number 1 on which one? The fraction to mixed number or mixed number to fraction?
The fractions to mixed numbers.
Okay, so fractions to mixed number, go back over that one real fast. Okay, so what would be the biggest question? Is it the first step or just the whole thing?
First step.
Okay, so the first step, we want to see how many times can 8 go into 12. Remember, the multiples of 8 are 8 times 1 is 8. 8 times 2 is 16. Okay. So that means 12 cannot be divided by 8 evenly, right? Because the multiples of 8 don't allow it. So that means 8 can only go into 12 one time. But how much is left over after you do that? 8 times 1 is 8. How much is left over between that 12 and 8?
4.
4. And then remember, you rewrite it over the 8. And the reason why we do that goes back to the pizzas. And that's why I show you the pizzas. The pizzas are to show you why we're doing what we're doing. We don't just make it up. It's based off of reality. So once you get there, you notice that those are 2 even numbers. And those 2 even numbers can reduce. And so you need to find the greatest common factor between 4 and 8.
Okay, got it. Thank you.
All right, perfect. And just to finish it, the greatest common factor was 4 and 4, and that gives us 1 and 1/2. All right, so on Tuesday, we're going to pick this up, and we're going to be doing stuff like this: 2.5 subtract 3 1/4. We're going to learn 2 different methods to do that.
I wonder if I got these right.
The first method people like, the second method people don't like, etc., and vice versa. So you can choose which one you like when we get to there. You can try that and see if you have it. You can send it to me, the answer, if you want to do that. and send it to the Remind group. All right.
Can you tell me if I got these right?
Which ones? From where?
On the right side, 2 and 3. I got 9 7s, and I also got, after that, I changed it to 1 and 2 7s. Is that right?
Yes, that's correct.
And number 3, 10 over 3 equal also 3 over 1/3.
3 over 1/3. Yes.
Okay, I just want to make sure I got it.
All right, you got it. Well done. And practice makes progress. Fractions is something you really want to practice and master, because we're going to come back to it in ratios and proportions, probability and statistics, and all throughout algebra, and also in geometry. And of course, it's going to get more grand. And so you really want to make sure you understand it.
Yes.
Right?
That's funny. I don't remember ever doing this stuff.
Hey, just build upon each other. Remember, try to explain it to somebody as well. Okay, if you're new, I just need to get you the Remind code. So if you're new, please stay behind. And Daniel C, if you're not busy, you can either wait till I just get that to you, the information I was talking about, or I can send it to you in Remind. But for those who are new,
either way.
all right. So those who are new to the class, if somebody has a Remind code in front of them, they could just share it. If not, just wait for me to get that to you. And let me stop sharing. But for everyone else, if you have no other questions or concerns, enjoy your weekend. Remember to look for the worksheet that's coming up. Practice that.
Okay.
If you're willing, you can go ahead and practice the workbook problems, and we can go over it on Tuesday if you have any issues.
All right.
Thank you.
Thank you.
You're welcome.
Thank you.
Thank you. Good night, guys.
Thank you.
You're welcome. If you're new, just wait till I send the Remind code. Make sure you either download Remind app, or you could go on your computer to remind.com. But that's the code that you want to put in if you were a new student. It's once you join it, it's going to ask you for a code. That's the code there, @mathDOU. That's the code to join. That's where I upload the worksheets. All right, Daniel, what I'm going to share with you is something that will allow you to go through the course at a higher pace. And I'm just going to send you the website real quick. Does anyone else have questions? I see there's some people here. I just came back on. Lenore? You're muted.
I get confused. You said we're going to be doing fractions still on Tuesday? So
yes.
We work on lesson 4 still?
Yes, we're still on lesson 4. You can try some of those problems. We didn't get to everything. So if you're having challenges, don't worry about it. But I'm sending a worksheet, so you want to focus more on the worksheet.
Yeah, because I'm not understanding this at all for some reason.
Yeah, I was moving a bit faster than usual, and that's because it seemed like a good bit of people remembered it.
Yeah.
So I did speed up the pace. Normally I would go slower. So I'm going to send the worksheets out, work on it. If you have any questions, just send me a message saying, can you help me here or there, etc. But don't feel stressed. I can always slow down a bit. I just wasn't sure where everyone was.
Yeah, it's okay. I mean, I haven't done this for years.
Don't feel bad.
So
don't feel bad at all, because fractions is normally the most challenging.
Okay.
All right. So
all right.
Just
thank you.
You're welcome. Once I send the worksheets, practice, practice, practice. And wherever you have an issue, just let me know.
Okay.
All right.
Good night.
Yeah. Good night. Have a great evening.
You too. Bye.
All right. So Daniel, right now I've sent you the website, and then I'm going to create an account for you for that. And so just bear with me while I'm doing that. I'm doing like 2 things at once. George and Maritza, do you guys have questions?
Let me see on Tuesday, because I'm doing the lesson 4. I'm going through following the main workbook, the main student book.
Okay, you have questions from there, you're saying, or?
Actually, for now, I don't have questions, but I will see how I can deal with those.
Yeah, go ahead.
Exercises.
Go ahead and try that, and let me know if you have any questions on it, because we haven't got to that part yet. So see how you do on it.
Yeah, then on Tuesday I will give you a reply whether it's best known to my knowledge or not.
Right.
Yeah.
Well, that's good. I like the ambition there. And I might see if I could get you a voucher, George, because you seem to have a good understanding of this stuff as well. So we got different levels here, so I'm gonna work with everybody.
Yeah, no, and I completely understand. You know, I'm actually remembering more than I expected to be honest with you. I haven't touched this stuff in years.
So I could see that you're getting it fast. That's why I'm like,
yeah, and I do have an account in Apex Learning for the science portion, so I don't know if I could get into the math portion of it.
I'm about to create one. I'm gonna put you in my other class right now.
Okay, sounds good. And then my test is October 7th. So between now and then, I'm going to be full participating because the more I learn between now and then, or practice is only going to be better for me.
Right, and that's why I want to do this, because we're not moving as fast as I see that you're able to go, and so I want to make sure that you can have some more stuff to help you practice.
Yes, correct, and I appreciate that, Mr. Ray.
No problem. Okay, so you're going to use your same password. I just put you in there. Do you remember your password for science?
Yeah, I have it written down, so more than likely I'll be able to get in.
All right, so you're going to see when you log in now, you're going to see Fall 2020 HSC Math, or it's going to say Math Reasoning, something like that. But that new one, that's my class. So you can just go ahead and do it on there. And it works similar, you know, it just you choose the topic of your choice, and it works just like science.
Correct. All right.
All right.
Well, I appreciate your help, and we'll see you on Tuesday. We'll see you on Tuesday, right?
Yeah, Tuesday, 6 o'clock.
Okay, thanks.
All right,
have a good
great
weekend. You
yes,
too.
you as well.
Bye-bye.
All right, bye-bye. Okay, George, did you have any other questions?
I don't have any question for now.
Okay, and Maritza, are you still there?
Yes, I do. Where would we get the assignments that you said?
That's on Remind. So did you find that, or do you have it already?
No.
Okay, so if you have a smartphone, you can download the app. It's called Remind, which is REMIND. If you're doing it on computer, you can go to www.remind.com. So it's just called Remind.
Okay.
And it's kind of like a Facebook for school. But that's where I just upload it. It's just easier to do that way than trying to get onto my email address and then read through all the emails from students from different classes and administrators. I can find whatever.
Do we need a password or username?
Yes, that's what I sent. Did you see the thing I sent? Here?
Let's see.
It's @math.dou.
Okay, that's the password?
Yeah. Now, if you want, I can send it to your email address. If your email address is the same as what's in the system, like you use it, I can just add you to the group and you just accept it.
Yes, it is.
So your email's working and that's the one you use?
Yes.
All right, so I'll do that right now and you should see it pop up in a moment once I find your email address on the system.
Okay, sir.
Yes.
I will try that of the internet. I don't know how will I meet up.
Say that again?
I mean, to go in, that just to try any exams using the internet.
Oh, you mean the GED practice?
Yeah, practice.
Hold on real quick. Maritza, what's your last name? I'm on here, but I can't see it.
It's SOLORIO.
Okay, I see it. Hold on real quick, George. And it's the iCloud one, right?
Yes.
Okay, and I'm just gonna have you set up real fast. And can you spell your first name for me? Because I'm not on, I can't see.
Yeah, that's fine. It's MARITZA.
Okay. All right, and you should see it soon. I just sent it. You should see an invitation pop up. It's going to say like Mr. Ray or my email address is inviting you to join Remind, something like that.
Okay.
Yeah, and so you just say yes, and that's where you're going to see the worksheets and other announcements pop up.
Okay, and then that's what we work at, like for homework. Okay.
Yeah, and what you want to do as well, once you get on there, it's going to ask you, do you want to, I can't remember the exact wording, but it's going to ask you, do you want to populate previous conversations? Click yes, and then the other files that I've sent are going to show up.
Okay, perfect.
Don't click yes, you won't be able to see the previous stuff that I sent.
Alrighty.
All right, and if you just have any challenges you forget, just let me know.
Okay, I got the email already.
Okay, yeah, perfect. So once you download it and stuff, it's gonna ask you and prompt you to do stuff there.
Okay, yeah, I added you already. Thank
All right,
you.
perfect. All right, have a great weekend and see you on Tuesday.
Thank you likewise. Bye-bye.
You're welcome. Okay, bye. All right, so George, you were asking about the practice test?
Yes, sir.
You mean the one on my GED?
Yes, just give me so that I should try it.
Oh, okay, so you do want to try it. So I never sent you a voucher, right? Because I know I sent one to a few people, but I don't think you had asked me at the time. You had asked me?
Yeah, I wanted to do it.
Okay, so let me get you a voucher. I think I have 3 left. So do you know the website?
I don't know, sir.
Okay, so I'll send you the website as well. Let me see. Hold on, I just have to remember who sent it to me. GED voucher. They come from the school.
Okay.
All right, so here's the voucher. I'll send you the voucher first, and then I'm gonna send you the website. Okay, so that's the voucher number. Do you see that?
Voucher, okay. G-E-P-L.
Right. It's cap sensitive, so you have to make sure it's capital letters. Now let me send you.
Send it again. Put it again. Let me copy it completely.
You should see it. Can you open it up in the chat?
So just send it on the wall. Let me see it.
It's you should be able to open the chat message. That's where I sent it.
Okay.
Do you see it?
I've not seen it.
Do you know how to chat to send the messages?
No.
Are you on a computer?
Yeah, I'm on computer.
Okay, take the mouse and scroll down to the bottom, and you should see something pop up. You should see like chat, participants, mute. Do you see that? Okay,
I've
click
seen
the
it.
chat button.
The chat, okay. Yeah.
And now you should see a message from me. Do you see it?
Okay. Thank you, sir.
Right. So that's when I'm saying send answers, that's where people are sending the messages to. So you have to click that button down bottom.
Okay.
All right. So make sure you get that right. I'm going to get the email, the website for you. Just hold on real fast.
My email address.
Say that again.
Are you asking for my email address?
Do you have to enter it?
I don't get you. I was thinking you're asking for my email address. I've copied the information.
Okay, yeah. So hold on to that. I'm just trying to get the website for you because you're gonna have to sign up and stuff. Okay. So hold on real fast. I'm trying to do 2 things at once, trying to find the website. Okay, here it is. All right. Now, when it comes in here, you should be able to click the website. Do you see it in the chat?
Sir?
Do you see? I just sent you something else in the chat.
Let me click there. Let me
click on that.
Oh.
And it should take you to a website. Do you see the website? Did you click what I just sent? It's a hyperlink.
Okay, I will copy it, then I will know what to do later.
Just click it. Just take the mouse and I click right on it.
Okay.
Just click it, and it's going to take you straight there.
What's going on? Okay.
Did you get it?
Okay, it is still. Yeah, now I come completely. I'm waiting.
Did you get this website here? This is what should pop up.
Yeah, I've got it, sir.
Okay, so once you do that, you're gonna. If you don't have an account already, you see here it says already have a voucher, log in or sign up. Okay. The number that I gave you, that G and all that stuff, that's the voucher number. If you already have an account, you log in. If you don't, sign up And once you sign up, you're going to have to put the code in once you're done.
Okay.
Right? So you click sign up, and then you're going to put in all the information. And then you're going to remember that. Right? So you want to sign up for it, put your email address, create a password. Once you get in there, that's when you can do the practice test. You're going to have to put the voucher in, or else you're going to have to pay it yourself.
Okay. I already have an account. I have, I think, let me see, $12 pending.
You put the voucher in?
Yeah, I did that. My brother did that to me. I tried some other one like social study the other time. So I still have balance in my account.
Okay, so now you have an extra balance, so you can take multiple tests.
Okay.
If you use the, are you going to use that voucher? If not, I could give it to someone else. But if you want it, you got 3 tests.
I need it. I will still use this.
Okay, yeah. So if you put that voucher in, you're going to have $18 balance, and you have the option to take 3 tests.
Okay.
All
Thank
right.
you.
You're
Yeah.
welcome. All right. Let me know how you do once you do it as well.
Okay.
All right.
Bye.
All right. Have a great evening. Enjoy your weekend.
Okay. Next Tuesday.
Yes, next Tuesday. All right. Bye-bye.
Okay. Bye.